Hi, welcome back to the channel. Thanks for tuning in again today. As you can see, Rotax 582, unfortunately, it has these aftermarket pistons in it. So this engine, as well as the one that was featured in the previous video about aftermarket pistons, are they really cheaper, has the same pistons in it. The difference is, oh yeah, and by the way, these are like right together in the same location, is they rightfully were nervous with this engine, pulled the exhaust manifold off, looked in the cylinders and went, oh, it's already got striations and scuffs in the cylinder wall. And this one only ran about 5 hours, I think it was. So very, very little time on it, it's already scuffed. So anyway, let's take this apart and find out what we can do, what we can use again, and if we can repair this and turn this back into a serviceable, long-lasting aircraft engine. The gearbox is removed, magneto flywheel is off. Next thing to do is to take the stator out, but then it comes, like, look at this wiring here. Seriously, it's all taped. So on a pre-flight inspection, could you see if something was almost, gonna lose contact in there? No, because you can't see it. It's all taped up. Can this all hold water? Absolutely. Corrosion in the wiring plugs, that's just what we want, isn't it? And then again, it's not fastened. So it can go like this in the wind, and the wire's right here or up in here. Like a paper clip, you can only bend it so many times. It's going to break inside. So this needs to be open and exposed. If it's got some bare wires or some repair, it needs to be done properly so we can see it. So who knows what's hidden underneath this tape? We'll find out. Okay, let's find out what evils lurk behind all of this tape. Because all right, maybe it was just easier. The guy maybe took the wires off this, didn't know where they all came from, so this was the simplest way to put it back together. I don't know. All right, maybe if I started this end. All right, here we go. Oh, they tied in a knot. No idea. All right, so let's get the screwdriver behind there so I can pull it out to make sure that I'm not cutting wires and just cutting off this tape. And let's see what the, oh, okay. All right, so this wire right here is the kill wire for that magneto, or that coil, and it should go inside this plastic that apparently they didn't know how to get off, so they just split it. Oh, what's up here? Oh, a piece of fuel hose over top. Oh my goodness. Okay, well, anyway, nothing surprises me. Now, when I see this stuff on the outside of the engine, I just know what the rest of it's going to be like. But this is some indication of this is bent. Wow. Okay. See, this is why you don't bury this stuff, because if this wasn't all covered in tape, you'd see that all hacked on there and you'd go, oh my gosh, that looks awful. Well, yeah, it is awful. But when you hide it, nobody knows. Anyway, we'll carry on. This may be difficult to see, but hopefully I can get a good enough shot of this. And let me move the light here. Maybe it'll focus better. There we go. So I'm using the inspection, the boroscope light in the spark plug hole, and you see all the striations all going up and down. You can barely down further, I can see a little bit of crosshatch. The cylinder looks like it was finished with the super fine finish, so it didn't hold any oil, which didn't help things at all. But that's what you don't want to see when you do an inspection on your cylinders. So same inspection on the PTO cylinder, and oh, nice, focused right away. So we can see all the striations on there. We can see some, I guess I'll call it crosshatch. It seems to be, if you look at the hatch or the on the left side, or the more left to the center of the port, and then to the right of the center of the port, they're not even on the same angle. So I'm not quite sure what was used to hone this. I see, yeah. Anyway, I don't know how they did it. I wasn't there. I have no idea how they did it. They sandpapered it, they honed it, they did something to it. Whatever. Terrible finish on the cylinder walls. And like I said, we can, obviously we can see the striations on it. Now, what do we see in the cylinder head in the combustion chambers? Well, a lot of discoloration, and right in here, coking already from, I mean, there's so much temperature, especially in the squish area, because the rings are, pushing so hard on the cylinder walls, and there's really no good lubrication. So the heat is unbelievable. Then we just look at the color around the outside here. So that's not normal to see that. And see, it doesn't even wipe off. So, I mean, it's been running at a really high temperature right in this area here. So let's have a look in the tops of the pistons and see what we see there. What do we see on the piston tops, piston domes, is some piston wash here, a lot of black on here. It was running really hot, like in this localized area here, just above the rings. And on the mag cylinder, a little bit of piston wash there, and just a tick right there. And again, this is all, burned on, carboned up, whatever you'd like to call it, coked, just from the extreme temperature. Is just frying the oil that went in there with the fuel. Also notice these O-rings that seal the antifreeze in the cylinder head. You see the way they're all sort of trying to extrude out of their hole. And this is after, I think it was only 5 hours of running. So I mean, the heat in this area was pretty intense. So after a little cleaning there, we can see that this piston is 76.15 millimeters. So we'll see how that all adds up in the end. And hopefully we can repair the cylinders. So we'll take the cylinders off now, and that's why I have the engine standing on the mag end, because I don't want any debris to go inside the crankcase. So I'm breaking these free with the ratchet by hand so that I can actually see the approximate torque on these. That one felt pretty darn tight. Look how much ratchet handle I got out here. Well, I'll say one thing, they weren't going to fall off. All right. Wow. Yeah, I took the bolts out. There we go. There. Oh, so that must mean, is that an N, a Z? Who knows? All right, get this one off. Come on. Wow. They glue these on? I don't know. There we go. There's the washer that I dropped that I couldn't get out because it was under the gasket. You have to keep track when you're taking anything apart and make sure when you walk away, you know, you have the washer that's on the bolt and all that. That one fell in, it fell in that hole right there and went underneath the center section. I couldn't get it out. So I was waiting to get that out. Because we have to know where all of the pieces are. If we lost the washer, we cannot continue until we find the same washer. But anyway, let's get back to this, and I'll pull the pistons off and we'll have a look. While I was removing the pistons and I was rotating the crankshaft a bit, I could hear a squeaky noise. And I thought, okay, let me put the microphone down in here and let me see if I can get it in the right place to squeak again. Well, not as much as it was. I don't know if you heard it or not, but it's probably these cheap junk seals already starting to stick to the crankshaft. Let's split the case. And well, that's unusual. This is not that wide of a screwdriver. It won't fit in. All right, we'll go over here. Whoa, now that's a lot of silicone on there. They sell it by the tube, so I guess that means you're supposed to use the whole tube. Now, the whole time that I was dismantling this, up to this point, it's been very difficult to turn the crankshaft, to rotate the crankshaft, and it's the same. I can barely, I'm slipping on the PTO end, so there's something here I can get a better purchase on. And it is really, really difficult to rotate. That's not normal at all. So I'll have to find out what's going on as well there. Then hopefully it hasn't destroyed the connecting rod bearings from the debris, you know, of the ring scratching off the cylinder walls, all those little particulate in there. If it gets into the rod bearings, it's going to show additional wear on it, and that'll be the end of this crankshaft. So anyway, let's find out why it's so stiff to turn. So one of the things that can happen to these is if the impeller for the water pump isn't put on far enough, it can be dragging on the housing. So let's take this off. Find out if that's actually the case. And that's really stuck on there good, so. Oh, didn't even need bolts and it won't come off. There we go. No, it's still very difficult to turn. So, not that. The water pump looks as if it is pretty much in the right place. So that's fine. So that it's not anything to do with that. So we'll lift the crankshaft out and then find out if there's something in the rotary shaft that doesn't want to turn. Okay, crankshaft removed. No, the rotary shaft. Yeah, there is a little friction to it. Yes, but that I would say turns quite normally. And Yes, the bearings all turn. Oh, interesting. This rear seal is really difficult to rotate on the shaft. So this one not so much, but that one, I mean, okay. So I'm going to take the seals off, this seal off, and put it back in and see if it rotates any smoother than it did before. Oh wow, is that ever more towards normal now? That's interesting. I've never seen one tight from a seal like that before. But then again, we don't use, I don't know what this is, some aftermarket seal. So isn't that something? So we got a lot of friction just from this, whatever it is, aftermarket seal. I wonder if that was the noise that here was the mag end seal making a noise like it's sort of sticking or squeaking on the crankshaft. Interesting. I'm going to slip this. Come on, mag end seal out. That's much more normal to turn now. This is the amount of friction that I would say is normal to rotate this. I don't need to grip it with all my strength. I can turn it. There's even oil on this end now, so that's more normal. So these that's the difference. So this is the um, aftermarket, low price, I guess high drag or high friction seal. Um, I would never ever use these things. If it doesn't have a Teflon lip on it, it's not going in an engine here. That's for sure. Thankfully, at first glance, this looks like the factory finish under all this silicone here. Thank goodness. So I'm going to take it over to the blaster and we're going to clean it with walnut shells, the same as I did on the other video of how I clean these. And, you know, this is like way too much silicone. Come on. Anyway, I'll find out for sure momentarily. I still have more cleaning to do on these crankcases, like get the gaskets and everything off. But first, what I wanted to do was find out if the sealing surface was damaged. And when I cleaned the lower part first and it looked perfect, now I've finished the other half of the crankcase, the cylinder side, and this is the original finish on here. So maybe from the time that he did that, whoever did it, by the time they did the first engine with some power tool, maybe they watched the video that I put out on how to clean this without wrecking it, because this was cleaned without any damage to it. So isn't that great to see that? I kind of figured it would be the same as the other, but I'm very happy for the customer to see that this crankcase is reusable. On my initial visual inspection of this crankshaft, I see it's got different pins in it for the connecting rods. Both of them are different than standard, so it's been apart. Also, all of the bearings in it are those, what I consider the cheapy ones with a steel cage in them, not what you want on an airplane. And then I brought it over here. Let's find out if it's straight or not. So let's find out how good of a job that this rebuilder did, whoever did it, and how straight, what's the concentricity on this crankshaft. So here we are set up in the center bearings here, as you can see. It's on, oh, they're both on 0. Okay. So let's see what we get. That is, let's say I give that one 1.5. This one is about 1,000. Let's move and see, what do we have on the PTO end? Whoa, look at the movement on that. That's, I go 3.5 thousandths on that one. And let's see what we get now on the mag end. Oh, another big mover there. Oh, 4 thou on that one. Now, I don't know if you remember from any previous videos or if you look at the specs in the manual, 2000s is absolutely the maximum run out on these. So it's double what it should have. So at 2 or over, you're not supposed to use the crankshaft. This has got 4 thou. When I rotated the crankshaft, I could feel a little rumble in it. It went a little faster, and I could hear a noise coming from this bearing. So I'm just going to put my mic right on the stand here. I'll rotate the crank, and we'll see if you can hear the same noise from that bearing that I heard. Okay, so that's what you get with a cheap steel cage bearing. You know, this thing apparently has got 5 hours on it. And can you imagine how much noise that would be making at 6,000 RPM? How much vibration would come from a bearing like that? And that's just one of them. There might be other ones that are just as noisy. But just wanted to give you an example of that. I mean, this is what happens when you use cheap junk on an aircraft engine. So where do we go to from here? Well, what do we got? We ended up with aftermarket pistons. Again, poor ring package, terrible finish on the cylinder walls. So we need to put some real Rotax aircraft pistons in it. We need to bore the cylinders. And as you've seen, I mean, there's no way I would even consider using that crankshaft in any kind of an airplane. I'm sure it's probably fine in like a snowmobile, personal watercraft, something like that. But you just can't use a crankshaft like that in an aircraft. It's just not worth it. It's so crooked. And is it even phased? So what I mean by phased is, phased properly is that the pin in the connecting rod is here and the other one is here offset. It should be exactly 180 degrees from one to the other. I never checked it. Is it right? Probably not, but I don't really know. Not interested in it. I've got enough inspection into that now to know that that wouldn't be in any engine that I would ever put together for use in an aircraft. So we need to get a crankshaft, as I said, pistons, bore it, seal kit, put this engine all back together so that it has the proper aircraft components in it. And then find out, well, what's the cost on that? How much is it going to be to fix this thing? Versus maybe for not much more, maybe a little bit less, we'll end up to buy a new short block. So if there's any left. So let's have a look at it. I'll find out what the pricing is, and the customer can decide which way he wants to go. So again, these cheap parts are not worth it. What can I say? Some people use them when they work and they get by with it. It's not for me at all. So thanks for tuning in today. Thanks for the time you spent with me. Like, share, subscribe, all those other things, and we'll see you again. Safe flying out there. Bye now.